Welcome back, students, to the next video for online classes in pharmaceutical microbiology. The previous video we have dealt with the biochemical test, that was IMDIC test, which includes indole production test and M for methyl red test, VI for Wasgate for Kurz test, and the last was separate test. All these tests are required to identify the type of bacteria present. Okay, and whereas the staining techniques, the first topic of our second unit, that was also with respect to identification of specific species of microorganisms such as bacteria. Okay, and today's class will be studying about sterilization topic. Okay, what is sterilization? Basically, in order to make ourselves clean or anything that we use, if it has to be clean, we use some specific agents in order to make it pure, in order to make it uncontaminated. So what are those? We'll be studying in today's class. So today's class objectives will be to know what actually the sterilization is. Okay, and after that, what is the purpose of sterilization? Whatever we do in science, there will be a specific reason. If we are taking some paracetamol, there is specific reason because we have fever. For that reason, we take paracetamol. There is a specific reason for each and every act that we do in science. So what is the purpose of sterilization, that will be seen. After that, there are a few definitions that you need to understand or you need to remember, like what is a sterilization, what is disinfection, what is aseptic condition or asepsis, what is antiseptic. All these will be studying in the coming slides. After that, we'll be seeing about classification of sterilization. You know, sterilization can be done in various methods, like using of solar, sunlight, or UV light, or any other agents, chemical agents. So there's a classification of sterilization. We'll be seeing that. And after that, we'll be studying about the various sterility methods. How do we sterilize various equipments or places and all? Okay. And after that, we'll be studying what are the advantages and disadvantages. It means merits and demerits. So beginning with what sterilization is and why sterilization is needed. Basically, sterilization is a term used to decontaminate or to clean some places, or let us take our hand itself. Because of this COVID situation, we are continuously sanitizing our hand. What is sanitization? Removing of some harmful microorganisms from our body. Okay, that is called sanitization. And basically, sterilization means making the place sterile. What is sterile? Free from microorganisms. So what is the reason for sterilization? Why do we need to do sterilization? As you know, microorganisms are present everywhere in the surroundings, right? Could be even in the place where I sit, or the benches in the classrooms, even in the air that we breathe. Everything has microorganisms. And in order to make free from microorganisms, we need certain sterility methods. Where do we use these sterility methods? The first thing can be operation theaters in hospitals, because in hospitals, before going for operation, the place has to be sterile. Even if some microorganisms are present, the patient might get exposed to those microorganisms and can cause various diseases, isn't it? So for that reason, we need to make the place clean or sterile. And in industries, you know, all the formulations, let it be tablet or capsule or syrup, anything formulation, whatever is prepared in the industry are sterile, free from microorganisms, isn't it? How are they? Why are they free from microorganisms? Because they maintain certain sterility parameters. What are the sterility parameters? We'll be studying in coming slides. So microorganisms are capable of causing infection and are constantly present in external environment and on the human body. As you know, even on our skin, there will be a presence of microorganisms. Microorganisms are responsible for contamination and infection, isn't it? So the aim of sterilization is to remove or destroy them from materials or surfaces. Whatever the surface or whatever the place that we use, that should be sterile. In order to make that place sterile, we use sterility methods, could be either physical or chemical or mechanical. We'll be studying that in the coming slides. Moving on with the various methods of killing microorganisms. How can we kill microorganisms? The first can be denaturation of proteins. Every microorganism is capable of synthesizing protein. Microorganism itself is a living organism, isn't it? Every living organism has nucleic material. That nucleic material, specifically RNA, that goes for transcription and then translation, resulting in formation of new proteins. That new proteins can be harmful to our body, right? So if we destroy those proteins, there will be death of microorganisms, right? Or else there are certain proteins which are responsible for the survival of uh, microorganisms. For example, the proteins coming from the ribosomes. Those proteins, if we kill them, there will be no protein production and there won't be any further generation of microorganisms, isn't it? So the first can be denaturation of proteins, and for that, wet heat and ethylene oxide are used. So we'll be seeing what wet heat method and how ethylene oxide is contributing in sterilization methods. Next is oxidation. When I say oxidation, always remember production of free radicals of oxygen. Oxygen, molecular oxygen is O2. When I try to get radical out of it, it will be O with a dot. O with a dot will be an oxygen free radical. If it is O2, it is oxygen molecule or molecular oxygen. This oxygen free radical attaches to the cell surface, okay, with the cell membrane. As a result, it causes mutations or oxidation of that particular location of the cell, resulting in breakage of the cell, and all the components inside the cell will come out. That will be leakage of the internal components of the cell, resulting in death of the microorganism. Next is filtration. The filters that we use at home, we have certain cloth within that or cartridges. The water passing through it will capture or will absorb the microorganism within them and gives out the pure water. And next is interruption of DNA synthesis or repair. UV light. Why does the doctor prescribe the patient to sit in UV light in the early morning hours? The reason is the light coming from the sun in the early morning, that is blue color light, also called as UV light. That light, when falls on the skin, there is a different range of UV light that when comes in contact with the microbial cell, it causes mutation and death of the cell. So we'll also study in brief how UV light is contributing to sterilization in the coming slides. And last is disruption of cell membranes. So basically alcohols are used to disrupt the cell. When the cell membrane itself is disturbed, it gets broken. As a result, the internal components gets leaked out. So let us move on to understand the definitions of sterilization methods. First is sterilization itself. So it is a process by which the article, surface or medium is made free of all microorganisms, either in vegetative or spore. So microorganisms can exist either in a vegetative form, that is growing cell form, or spore form, that is a dormant state. Okay. So sterilization can be used to either stop them or to completely remove them. And the next definition is disinfection. What is disinfection? Let us see. Destruction of all pathogens or organisms capable of producing infections, but not necessarily spores. All organisms may not be killed, but the number is reduced to a level that is no longer harmful to health. The best example we can take is the advertisement that we see for Dettol or any other soap. Before washing with a soap, what they see through microscope is presence of many germs under the microscope. After washing, they'll be seeing only 2 or 3 germs present. What does it mean? It means that particular detergent or that particular soap or any other reagent used is causing the microorganism, is reducing the number of cells of microorganisms. Okay, it means it is making the microorganisms less effective. If they are more in number, it could be more effective on the human cell or human body. If they are less in number, they might show negligible effect. As a result, we get no problem. We won't have any effect of the microorganisms. So basically, Dettol or the disinfectants that we use on the floor, such as phenol, Lysol, all these will be helpful in reducing the number of bacteria, but not completely removing. Okay. And next is antiseptic. You might have heard this term antiseptic. What does it mean? It means prevention of septic. What is septic? It is a kind of infection caused by microorganisms. So antiseptic are the chemical disinfectants which can safely apply to living tissues and are used to prevent infection by inhibiting the growth of microorganisms. So antiseptics can include all the antimicrobial agents, antifungal, anti parasites. Okay, all these agents come under antiseptics. Okay, and next is asepsis. What is asepsis? Sepsis means infection. Septic or sepsis are one of the same. Septic means infection. Similarly, sepsis means infection. What is asepsis? Which prevents infection is called asepsis. So it is a technique by which the occurrence of infection into an uninfected tissue can be prevented. So these were the definitions with respect to sterilization methods. Moving on to the fact or the characteristics of a particular reagent in order for it to be give more efficiency in sterilization. What I mean to say is, if I use a particular compound, it should be so convincing to me that it should be more efficacious, that it should have more efficiency, it should be low cost, or it should have compatibility with my skin. Even if it falls on my skin, it should be safe. Okay, there are certain characteristics of all the sterilization techniques. We'll see what they are. Okay, we can tell them as ideal sterilization or disinfection process. Let us see what they are. It should be highly efficacious, which means even in small concentration, it should be able to kill most of the microorganisms. It should be fast acting, okay, and it should have good penetrability. What is good penetration capability? It means that particular reagent should be able to penetrate into the cells of the microorganisms, causing the death of microorganisms. Next is compatible with all materials. Whatever we store all the disinfectants used, could be a plastic bottle or a glass. That reagent or that solution or that chemical compound should be compatible with the container in which I keep the chemical substance. So it should be compatible with all materials, and it should be non-toxic, because if sometimes while cleaning it might fall on our hand. So if it falls on our hand, if it causes irritation, it might cause some other diseases, isn't it? So to prevent that particular substance, chemical substance, should be non-toxic, and the effect despite presence of organic material. It should be effective even if any other materials, organic materials are present, such as let us consider blood. I got a I got some I have faced some accident, and as a result I got a wound. On the wound, after despite I have the trauma on my skin, that is the wounded part, I'll be having blood around it. What does it mean? That it can be possible that the microorganisms might have settled on the blood and might cause infection in coming stages, isn't it? So when I put a particular substance on it, it should be compatible so that even in presence of blood, it should be more effective. Okay, the point effective despite presence of organic material means this one. And difficult to making significant mistake in process. It means it should be simpler in preparation. If I consider alcohol preparation, it will be a very simpler one. If I go for any substance which is difficult to prepare, that will be a costlier one, isn't it? If it is costly, no one will purchase. So it should be so simple in preparation that it will be more efficient or more economical for the customers, and it should be easily monitored. These are the ideal characteristics of sterilization or disinfection process. Okay, and let us move on with now let us see what are the different types of sterilization methods. Beginning with types of sterilization. So as discussed earlier, sterilization can be of various types: physical, chemical, or mechanical. We'll be studying about physical and chemical in our classes, because the mechanical part also is included within the physical part. So beginning with physical sterilization, there are various methods of physical sterilization, such as heat sterilization. Within heat sterilization is moist heat sterilization, dry heat, okay, and pressure, that is called pasteurization, and sonic, solar disinfection, filtration, radiation. This filtration and sound comes under mechanical methods. So I'll be dealing even those in physical, so that I need not discuss separately the mechanical part. So beginning with heat sterilization. You might have seen the infants who are feeding on the milk. The parents, what they do is they take the bottle through which the child is fed. They take it and put it in a boiling water. Okay, that is a type of sterilization in order to keep microorganisms away. After they boil it, the bottle in water, boiling water, then they add milk and then give it to the baby. That is a type of sterilization method. So basically, his sterilization is most effective and widely used method. Okay, and and it is very easier. It can be done by even a lame people and causes destruction of enzymes and other essential cell constituents. It is very convenient to follow this method, and it causes degradation of all enzymes, because all enzymes are proteins and proteins are very sensitive to heat. So it can cause destruction of various enzymes released by the microorganisms. But it cannot be used in case of compounds which are heat sensitive, such as the enzymes which are required to our body. Best example can be insulin, and the vitamins, the vitamin D, lipid soluble vitamins, they are very much sensitive to heat. They cannot be heated in order to make it sterile. Okay, and it occurs more rapidly in fully hydrated state, as it requires lower temperature and less time. If a bacteria is present in a hydrated state, suppose in presence of water, if I boil, the water contains heat and it also contains latent heat. What is latent heat? It is a hidden heat stored within the molecules of water. That hidden heat penetrates into the cell surface, cell membrane or cell wall, and then gets into the cell and causes destruction. Okay, and under circumstances of thermal degradation, high temperature for short period generally result in lower partial degradation. What it means is, if we have to sterilize certain compounds which are not heat sensitive, then higher temperatures, it could go for 120 degrees centigrade, 130 degrees centigrade, 150 degrees centigrade. To higher temperature it can be taken for less time, so that we can achieve a proper sterilization. It causes partial sterilization, not complete sterilization, because the cells will be destroyed but not completely killed. They will be either in dormant state. Okay, and applicable to thermostable products. It is applicable to thermostable products, right? And still it can be applied to both moisture sensitive and moisture resistant products, for which two methods, which are dry heat and moist heat, we'll be discussing in the next slides. So basically, dry heat means heating of a compound with 160 to 180 degrees centigrade of temperature. 160 to 180, it is very hot, which means there won't be any presence of water molecules in them. Whereas moist heat means it is below 100 degrees centigrade. Okay, around 120 to 121 to 134. At this temperature, there will be a possibility of presence of water molecules. For that reason, it's called moist heat sterilization. So beginning with the moist heat sterilization, when I say moist heat, you can remember the presence of water in sterilization method, which means boiling, right? The best example is autoclaving, or from the live examples that you want to see, it will be a kettle. So you can see the image here, the kettle. When we pour water in that, even if you want to heat it, after achieving a particular temperature, pressure will be released. That pressure release is an indication that a particular temperature has been reached. So similar in autoclave, when a substance is kept into that, water is added. That water is boiled at 120 degrees centigrade, and the pressure is when water is boiled, pressure will also increase. So in cooker, the pressure will be stored. After a particular pressure is reached, that pressure helps to penetrate within the soil, within the cell membrane, and destroy the cell. As a result, we get pure sterilization. Let us see what it is. The steam at temperature 121 to 134 degrees centigrade. Steam, which means it contains water molecules. Under high pressure acts as bactericidal. What is bactericidal? Which means which kills the bacteria. What is bacteriostatic? Which prevents the growth of bacteria. Okay, and facilitates the rapid penetration of heat, as discussed, due to high pressures. Moisture present in the steam causes coagulation of proteins. The heat, that much high temperature of heat, high temperature of water molecules cause coagulation of the proteins. Okay, irreversible loss of function and activity of microbes. So because of high heat, the proteins are losing their nature. As a result, they are getting sterile. They are not able to survive. Okay, and higher levels of sterility is assured in this method. Most commonly used standard method is this is the most commonly used standard method, right? If the bacteria are present in spores, what will be the condition? Let us see. The most commonly used standard temperature time cycles for clinical porous specimens. Example, surgical dressings. The best example is using of surgical equipment such as scissors or stethoscope. All these, not stethoscope, scissors, and they have forceps in order to do surgery, isn't it? So all those surgical dressings and bottles which contain fluids such as saline bottles, all these has to be heated at 134 degrees centigrade for 3 minutes in order to get it sterile. Or if not 134, it can be heated to 121 degrees centigrade for 5 minutes. You can observe higher temperature, less time, lower temperature, higher time. Okay, an autoclave is a device that works on the principle of moist heat sterilization through the generation of steam under pressure. The autoclave, the best example that can be taken is a pressure cooker that we use in our homes. When we add dal into that and start heating after adding some water, because of heat produced, the boiling water, the proteins, that means the dal or the cereals, completely coagulated. As a result, it gets broken up, the cells gets broken up, and we get a paste like them, right? Isn't it? So that is the best way to describe sterilization process in case of microbiology. In this method, the microorganisms are killed by coagulation, coagulating the proteins as discussed now. And this method is much more effective than dry heat sterilization, where microbes are killed through oxidation. In dry heat method, presence of high heat and absence of water results in oxidation of the cell membrane. Okay? Whereas that is not the case in moist heat sterilization. So in moist heat sterilization, it is below 100 to 131. Let it be. Okay, there are three different stages. Below 100 degrees centigrade, 100, and above 100. Let us see below 100. Basically, the pasteurization method that we follow, that is heating of milk in order to remove microorganisms, that is done at 63 degrees centigrade. Why is it done at 63 degrees centigrade? The reason is if we heat for 100 degrees, the milk itself is a protein. If we heat for 100 degrees, the protein itself gets coagulated and the milk will be ineffective if we administer that. Okay, it involves pasteurization technique. Okay, the pasteurization technique developed by Louis Pasteur. The milk is not heated above its boiling point, as the milk might curdle, which means it breaks. All the protein part gets break. All non-spore forming microbes are killed in milk. Okay, at 63 for 30 minutes and 73 degrees centigrade for 20 seconds. The flash trigger. The principle basically is logarithmic reduction in the number of viable microbes. By heating at 63 degrees centigrade, all the microorganisms which are present will be decreased in their concentration, which such that it will be having negligible effect on humans. All mesophilic non-spore bacteria can be killed. Okay, and beside milk, other fluids and equipment like vaccines of non-sporing bacteria are also pasteurized at 60 degrees centigrade for 1 hour in special water baths. Similarly, serum and body fluids. Serum is taken from the blood. Serum and body fluids with congeable proteins are also sterilized at 56 degrees centigrade. If it is heated above 60 degrees, that might coagulate. And if it is heated for 1 hour in water bath, it will be sterile. That is heat temperature 100 degrees centigrade. It doesn't ensure complete sterility, but is enough for the removal of pathogenic microorganisms and spores. That means it is effective for spores as well. Whereas below 100 degrees centigrade, that is not efficient for spores. Materials have to be immersed in boiling distilled water for 30 to 40 minutes. Whatever you want to sterilize, that has to be immersed or dipped into water for 30 to 40 minutes. Sterilization is a method that is used for sterilization of a media with sugar and gelatin at 100 degrees for 30 minutes. That means the nutrient medium that we prepare for culturing microorganisms, that has to be heated at 100 degrees centigrade for 30 minutes. Okay, for 3 successive days, so as to preserve sugar which might be decomposed at high temperature. If heated above temperature, you know, sugar molecules are also present in the nutrient media because sugar is a glucose. Glucose provides energy for the bacteria to grow. If that sugar is absent, the microorganism cannot grow. So it is heated 200 degrees centigrade so that sugar does not get decomposed. And applicable for contaminated dishes, beddings, pipettes, and other instruments, as well as for objects that are temperature sensitive. Moving on with temperature above 100 degrees centigrade, it involves sterilization by steam under pressure. Okay, steam, water boils at 100 degrees centigrade, and above 100 degrees centigrade, whatever we get, the liquid is in the steam form. Okay, the moisture present in the air, that will be steam. The hot water, the hot moisture present in that will be called as steam. Okay, it involves sterilization by steam under pressure. Okay, the best example is autoclave or pressure cooker. The boiling point of water increases if the pressure is to be increased. Basically, when you heat water, water vapors keeps on coming out. So when water vapor are coming, the vapor itself has some pressure, vapor pressure. That pressure continuously is increased, pressure also increases, isn't it? Okay, this principle is employed in an autoclave as discussed, where the water bath boils at 121 degrees centigrade at the pressure 15 psi, okay, pascals, uh, for or 775 mm of H, okay, millimeter of H. As a result, the steam under pressure has a higher penetrating power, as discussed, because of heat produced. The bacterial cell will get all the cells get a bit farther. The best example you can take to understand this concept is um, if we have some bottle with a lid on it, which is very tight and cannot remove. So what do? We put it in some hot water so that all the atoms present will get farther. It expands. As a result, it will be the cap will be looser and it will be easier to open. Okay. Similarly, the cell molecules will get separated because of heat. They expand. As a result, the heat, hot water can penetrate into it and destroy the cell components. So as a result, we can kill the microorganisms. Autoclaves are used for sterilization of contaminated instruments along with different culture media as it ensures complete sterility. Moving on with dry sterilization method. You would have seen autoclaves in our laboratories. So autoclave looks like this, and these are the stands where we can put our substance or any other like petri dishes or any glass wares. Okay, and when we close, we heat for 121 degrees centigrade for some time, we get complete heat sterilization. Okay, dry heat sterilization is the process of removing microorganisms by applying moisture-free heat, which is appropriate for moisture-sensitive substances. There are certain substances which are sensitive to moisture, which means it can absorb moisture. Okay, as a result, that get decomposed. The best example is sodium chloride. Sodium chloride, if we place in the environment, it immediately absorbs water from the atmosphere and gets jelly-like, or it gets sticky, and at the same time it starts degrading. Such thing, if heated at sterilized at dry heat sterilization method, there won't be any chance of moisture to be absorbed. Okay. The principle is conduction. What is conduction? Transfer of heat from one substance to other, or one object to other. Similarly, in case of microorganisms, heat will be transferred from one cell to other cell. Okay, one after the other, one after the other. Same amount, constant heat will be passed on. As a result, that microorganism will face to death. Okay, dry moisture less heat destroys microorganism by causing denaturation of proteins and lyses the proteins in many organisms. So basically, in dry heat, it undergoes dry heat causes oxidation of the cell membrane. As a result, the cell membrane gets broken. Or when I say broken, it means lysis. Okay, lysis the proteins in many organisms causes oxidative free radical damage. Okay, causing drying of cells and even burn them to ashes as in incineration. There are different methods of dry heat method we'll be seeing in the next slides. The lethal effects of dry heat on microorganisms are primarily due to oxidative processes, okay, as discussed, which are less effective when compared to hydrolytic damage that results from exposure to steam in moist heat sterilization. Despite it being not that effective as moist heat, it has certain different advantages over moist heat. This principle is used in instruments like hot air oven and incineration, which generates very hot moisture free air. Let us see different methods of first we'll see in what cases dry heat sterilization is used, then we'll go for various methods. Okay. Substances like oil, powder, and related products cannot be sterilized by moist heat because moisture cannot penetrate the deeper parts of oily materials and powders and destroyed by moisture. So as discussed, if we take powders and we try to sterilize by moist heat sterilization method, the moisture present in the air will be absorbed by the substance itself, the powders. As a result, it becomes like coagulated, or like stone, not like stone, it will come closer and forms a coagulated one. As a result, that will be ineffective if we use. Similarly, in case of oily materials If we try to do with moist heat, that is not possible. Moisture will be entrapped onto the oil, making the oil contaminated or adulterated. Okay. If we go with dry heat, there won't be any moisture and the oil will be safe. Laboratory equipment like petri dish and pipettes, all these petri dishes and pipettes or any other glassware that is used in either research or anything, we need few compounds to be stored in that. In order to get few compounds, that particular glassware should be free from microorganisms. How do we get that? That will be possible if moisture is not present. How can we remove the moisture? By dry heat sterilization method. The primary industrial application of dry heat sterilization is the sterilization of glass bottles, which are to be filled aseptically. In addition to the fact that this method achieves an adequate sterility assurance level, this method also destroys bacteria and endotoxins, okay, which are the products of gram-negative bacteria and also called pyrogens, which cause fever when injected into the body, which are difficult to eliminate through other sterilization methods. Basically, pyrogens are those compounds or those cells which are dead microorganisms and cause uh, pyresis, pyritic action in our body, that is increase the body temperature. So dry heat sterilization method also removes those and also other endotoxins which cause serious effects on the human body. So what are the types of sterilizations? Red heat, flaming, infrared, incineration, and solar. Okay, hot air, oven. Okay, all these will be studying now. After that, whatever are the physical or mechanical methods that will be discussed in the next slides. Next video. So beginning with types of dry heat sterilization, red heat, flaming. What is the difference between red heat and flaming? Red heat means red color flame, whereas flaming is blue color. Just understand that one. You can see the images here, red heat and flaming, how they are. Let us see what they are individually. This is red heat, not rest heat. Red heat sterilization is a process of instant sterilization by holding instruments in a Bunsen burner till they become red hot. Until they become red hot, it will be sterile. After it is red hot, we take out from the flame and come to room temperature, and that will be a sterile one. The best example is the rod that we use to inoculate microorganisms. The thin rod that we use, that will be first kept in flame, in the red flame, so that it becomes red hot. After that, we get it to room temperature and then use it for culturing the microorganism. This method is based on dry heat sterilization. Is commonly used for sterilization of instruments like incubation loops, okay, as discussed, wires and points of forceps. This process ensures effective sterilization. However, it is only limited to substance that can endure heating until redness is in flame. It means only those substances which can be stable even at higher temperature. Even if it reaches to red hot, it should be stable. Only those compounds can be used in red heat. Let us see what flaming is. Flaming is a type of dry sterilization that involves exposure of metallic objects to flame for some time, where the flame burns microbes and other dust present in the instrument. In case of flaming, the instrument is dipped in alcohol or spirit before burning in a gas flame. This process doesn't ensure sterility as it is not effective as red hot sterilization. What it means is, before we go for flaming, we need to dip the particular substance or particular object to be sterilized in alcohol, it could be ethanol and methanol, and then put it into the flame in order to achieve sterilization. However, this method is not as effective as red heat. In red hot is completely getting red color because of heat, and which destroys all the bacteria. Whereas in this case, it's not going to red hot. There will be a possibility of some bacteria which are not sensitive to heat can survive there. The next is infrared radiation. Infrared radiation are or IR radiation coming from the sun. Okay, these rays penetrate into the cell structure and destroy the cell. So basically, these are used in case of syringes to destroy syringes and other medical equipment. Let us see what they are. IR is a method of thermal sterilization in which the radiation is absorbed and then converted into heat energy. For this purpose, a tunnel containing a IR source is used. So you can see this one. There is a hole in this. Into this, the substance to be sterilized is placed. For this purpose, a tunnel containing IR source is used. The instrument and glassware to be sterilized are kept in a tray, are then passed through the tunnel on a conveyor belt, moving into a controlled speed. You can see this rod is being kept into the hole, and the IR ray is exposed. As a result, we get sterilization process. During this moment, the instrument will be exposed to radiation which results in temperature of about 180 degrees centigrade for about 70 minutes. You know, every rays coming from the sun, when it falls, when the electrons absorb, then they get to excited state and comes down to brown state. Okay, since they are unstable. During their coming to brown state, heat is evolved. That heat will reach to 180 degrees centigrade in case of IR. So IR is applicable for mass sterilization of packed items like syringes and packages. What is incineration? Incineration is the process of burning everything. What is burning everything? What does it mean? So whatever is not in use, that will be sent to incineration where it burns and converts the substance to ash. Let us see. Incineration is a process of sterilization along with a significant reduction in the volume of the waste. After we burn, when it is converting to ash, it means volume is getting converted, right? So it is usually conducted during final disposal of the hospital or other resources. Let us see the diagram here. You can see there is a hopper at the top. From here, the substance or compound or any other things to be insulated is added. This falls here, and due to higher temperature, it completely burns and ash is collected. You can see this image also. Okay, uh, the the chimneys, through the chimney, smoke will be uh, given away, and you can see this image. From this image, this is the place where we put the substance to be incinerated. Okay, unwanted substances will be kept from here. As a result, burning process occurs inside. The smoke will be removed out from the chimney. Okay, and this whole equipment is called as incinerator. Now, what is hot air oven? As discussed in the previous slides, hot air oven is like a square-shaped structure which contains different spans where you can put glasswares and all in order to achieve sterilization at a higher temperature. So basically, the temperature used is 170 degrees centigrade for 30 minutes, or 160 for 60 minutes, or 150 for 150 minutes. This is the process of hot air oven. Okay, the basic principle is conduction. That means transfer of heat from one cell to another in a constant temperature. And then filtration, all these are comes under mechanical methods of sterilization. So this is it with today's class. The next class will be studying mechanical methods that includes filtration and solar and all. After that we'll also see the chemical sterilization methods. So thank you for watching.